So, first of all, perdóneme, pero no hablo español. Sorry. But you are lucky. I do not speak with a Manchester accent, like my great colleague, Phil. So I'm from America, originally in New York City. I live in California, so I don't speak like with a New York accent. A New York accent is like this, and if I really talk really, really fast, you wouldn't understand what I say. Sort of like when I listen to you guys speak Spanish, I have no idea what you're saying. But I will not speak that way, because I know that most of you, all of you speak English, I think, right? 50%, 75%. How many people speak English, understand 75%? Great. Less than 75%? You can admit it, it's okay. Yeah, you don't speak shit. It's great. I try not to speak too fast. I'm an instructor very often, and I also teach a lot of students of multiple languages, so I try to make sure that I'm understood, because otherwise, what's the point, right? That's me. I've been an MVP 5 years in a row. My history in development, I'm a developer. I go back 30 years. Salesforce about 9, 10 years. I teach for Salesforce, for Trailhead, the classes, and I run a team of instructors that teach all across the Salesforce spectrum. I also build courses for Pluralsight, which is an online e-learning platform in America, Salt Lake City. And if you were outside in the front desk and you saw these funny stickers, you say, what the hell is that? This is a free pass for Pluralsight training. They have 7,000 courses. And most of them are, they're localized. They have a localization engine. They transcribe the course, so they're captioned, closed captioning. And there's a drop down, and you can pick the language, and it will translate the captions using machine language. It's getting better. Google engine, real time. So you can watch any 7,000 course, and you can see it in Spanish or French or Japanese if you want to speak Japanese. These are on the table outside, so please feel free to grab one of these and test it, because then you can watch a lot of courses for nothing. And so it's another one of those free things. I write, written for Salesforce on their articles, their blogs. We wrote a book years ago, Visualforce in Practice. It's in English, but it was interesting stuff on Visualforce. And I work with Salesforce internally. And I'm doing the closing keynote, and I'll give a little bit more information then, but I want to focus today on microservices. And a lot of people don't know. How many people know what a microservice is? Just hold up your hand. You know what a microservice is? That's great. Most people don't. Those of you who do, that's great too. But most people don't know what the heck a microservice is. So we're going to tell you what it is. We're going to give you an example of one. And then I'm going to demo one. I'm going to show you some code. And what I want to try to do is get through the slides very quickly. And I want to get into the demo, the code, so because then you see it and then your head goes, oh, that's what a microservice is, okay? And then I'll show you some links and takeaways that you can go do more research if you want. A typical perspective of microservices in the enterprise, not necessarily Salesforce, but in enterprise software development. What is it? It is an architectural approach. It allows for decoupling and the dissolution, taking apart, of monolithic application stacks, very big applications, right? Because the bigger an application gets, monolithic enterprise, they get harder and harder to maintain, to enhance, to extend. So this is an approach. Why? Because it makes it more scalable, more maintainable, and better performance across what we call an application of suites. We get to break down application functionality, breaking it up into little standalone discrete services, typically web services, each doing one thing very well. Almost like when you write Apex code and you write a method, best practice, single responsibility principle. Anybody hear of SRP, a software pattern? That method should do one thing. It gets an input, it has an output, it does one thing, right? And the key point here is that that service stands alone. It's not coupled to anything except what it needs, so it's self-contained. And you get a lot of them. And together, they make up a very large application if you want, or maybe a little application. It's your choice. Now, in the Salesforce world, we have a slightly different perspective of microservices. It's still a discrete service. It does one thing and one thing well. And its objective is to perform a single specific function not available on Force.com. So if you're writing Apex and you need something to happen when the Apex executes, but it doesn't work in Apex, you can't do that on Salesforce. The idea is you call out to the service to do the one thing and then come back and finish your job. And it's implemented as a service, deployed to some isolated instance, Heroku, Azure, it doesn't matter. Some platform where you can call it and get back something. That's it. It's very simple. Now, in the Salesforce world, you'll actually, I found this, I stumbled across this. This is in their documentation, and it's talking about how Salesforce can function as a collection of microservices to something outside, because we have Salesforce APIs, right? So you could set up an Apex class as a web service, SOAP or REST, and have something outside, call it, and it acts as a microservice. It's not really a microservice, but it's analogous to, it's similar to. It's an interesting article. If you're interested, you can go read that. But that's not what we're talking about today. We're talking about when you can't do something that you need to do in the environment that you're in, you implement it somewhere else with a microservice. So you're mitigating the fact that you can't, you're stuck, you can't do it. It's a way out. It's a way to do it somewhere else. Right? Now, target characteristics. It should fulfill a single function. It should be lightweight, it should be independent, no middleware. It should be, you just hit it, it comes back, very simple. It should be accessed using a consistent request response pattern that you're going to use for maybe others. And the idea here is your architectural design. You don't want them to be inconsistent. If you're going to start to grow an architecture of collection of microservices, you want them to be similar. You want to follow patterns. It's good software practice, right? That they behave the same way, they look the same way, maybe naming convention is consistent. If you have a lot of developers doing different services, it will work, but it will become harder to maintain over time. So you want to try to keep consistency, and you use any language. It does not matter. Anything that you are facile in that will help you get the service up quickly and into production quickly and able to maintain easily, that's what you use. And you deploy it, the easiest place to deploy it. The whole point of this is to get it working and make it stable and allow you to maintain it as easy as possible for you, for whoever the developer is. Because easy is good, right? Easy is good. It typically accepts input, because you got to tell it you're going to do something, but you got to do it with this, and it should send back whatever it gets back, whatever the process is. Right? It can be synchronous or asynchronous. The service itself can either be called with a synchronous protocol or an asynchronous protocol. And of course, why would you want to use one over the other? It depends. If it can be processed in less than 2 minutes, which is the typical timeout for a synchronous web request response, you do it synchronous. Apex will wait, right? If your process takes longer than 2 minutes, well, you better call it asynchronous or you'll time out. So you can use platform events. How many people know about platform events in Salesforce? It's fairly new. Okay. You want to go look up platform events. There's a Trailhead module on it. It's basically a message bus. It's Salesforce's message bus, and it's really cool, and it's very scalable. So you can use platform events. You can use any message bus. It doesn't matter, right? So that would be for an asynchronous microservice process versus synchronous. Whatever's easiest for you, again, it's for you, whatever gets that service quickly. Be careful. How many of you have written asynchronous Apex? Anybody write at Future or a queuable class? Okay. So don't confuse the synchronous or asynchronous service with synchronous or asynchronous Apex. Because sometimes we have to use asynchronous Apex for certain contexts, like triggers, right? You have a trigger, you want to call the web service. You can't call it from within a trigger. It won't allow you to make a synchronous web service call. So you call asynchronous Apex class, and then it comes back and it goes off, and then this thread, I call it a thread, goes and calls the web service. It comes back and does something else on a different thread. So that's asynchronous Apex. This is synchronous, asynchronous web service, the process on the other end. Two different uses of asynchronous and synchronous, okay? Now, I'm going to give you a use case, and this was my problem. This is how I got into this, because I had a problem. I get an email. I actually get it from Salesforce, because I contract to them. I don't work for Salesforce as an employee. I'm an independent partner. And I have trainers, and we go teach their classes, and they pay us. Usually, they do pay us, usually on time, too. When they're about to pay my company, they send me an email. The email has a PDF attached to it. And I wanted to get that PDF into Salesforce org. And I wanted to take the header information and the line items. These represent my invoices. And I wanted to push them into a custom object. If this information had come in the body of an email, no problem, because Apex can read an email. Anybody work with email services in Salesforce? Okay, so there's a way that you can tie into an address in the Salesforce org and send an email to Salesforce, and it will be routed to your org, and it will be routed into an Apex class, which implements an interface, which is the messaging inbound email, and then you can parse it. It gives you an object, which is the email. It gives you an envelope, and then it's a class, and you can read it. And I could read the body of an email, and I could parse text. Apex, you can parse text. I can also get the attachment. This is an attachment. You can't read inside the PDF. It's binary. You can't do it. So I got stuck. I wanted to get the data from the PDF into my custom object. Can't do it in Apex. No way. So I said, I know. I'll build a web service, and I'll pass the PDF to the web service. The PDF will scrape the web service will scrape the PDF and give me back the text, and then I can read the text in Apex. So that was my objective, right? So this is my overall solution. My clicker's not working very well. I get an email to my Gmail, and I forward it to the email service in Salesforce. It has the attachment. I have an email handler class attached to the email service. It knows to call another class where I encapsulate the management of the email. It calls something called my remittance manager class, which, because this piece of data, I call it a remittance. It's the object. It has an inner queuable class. That inner queuable class also is going to send out to the web service, and when it gets back, it's going to use this other class. This is just a helper class to process the data, and that's my service. So basically, it's just these two. I'm going to make a call out that's asynchronous Apex to this RESTful service on Heroku. It's going to get back the text, and of course, if I'm going to call out to Heroku, I need an endpoint. I need to whitelist, right? So I'm also going to create a named credential. That's where you would also put security if you wanted. I don't use it. It's just open. Right? So I have a lot of moving parts. But the only part that really matters is the caller and the service. Don't worry about anything else. Okay? That's why they're bold. Now, this is a sequence diagram that shows what happens when the email is received. The email goes from Salesforce to Gmail. Gmail sends it to Salesforce. That's the email service. The email service gives it to the Apex email handler. The email handler passes it to the handler manager. The manager pulls the data from that object, and it inserts a new object representing this payment, this remittance transaction. It also takes the attachment, the PDF, and it puts it into the remittance attachment. It ties it to the parent. It just pushes the data in. It doesn't get any data from the PDF. It just sets it up, puts it into the database as an insert or maybe an upsert. And then it calls this other class. Now, I have a red border here, and I don't know if you can see there's a blue shading here. The red border is just to show you that this is the core process that's going to call the web service. The shading is the asynchronous call to Apex to make the call out. And I'm going to zoom in a little bit more in a minute. I want to show you some of the code. It's not very focused, but the idea here is that I go and I get the remittance information, and that's where I push it into the remittance object, and that's where I push in the attachment. And that's where I call the manager, say, go send it off to the service. So that's the first block of code. And I'll have a sample code for you in a GitHub repo that you can look at and play with, and I'll show you where to get that. This is where it happens, right? So once it's set everything up, it calls this other class. That's where the queuable Apex is set up, and it's the queuable Apex that calls the service and passes the blob, the attachment, and gets back text. And it has some logic to parse the text, and it updates the same remittance record it created. Right? Goes back to the remittance that it created where there was no data. It grabbed the data through its parsing logic, and it pushed it in, and it's done. Okay, so this is where the service, the microservice, is being called, right? And that's the code. It's very simple. It sets up, gets the key, the object, it gets the attachment for the object. That is system.enqueueJob. That is how you call asynchronous Apex using a queuable class. That is a constant which has the endpoint. I'm going to show you where I get that in a minute. Tells it what it's going to do. That's the blob. And that's the ID. And this doesn't call the service. This sets up an asynchronous job to be called later by Salesforce. Right? So that's enqueuing it. And then it's done. Right? Salesforce takes over. This is the constructor that I'm using right here. That's just to set it up. It's taking these arguments, and this is just setting up some private attributes in the queuable class, and that is what's going to be called later by the Apex asynchronous engine. Right? So here is that's that same execute method. It's just very simple. Anybody who's called a RESTful web service should recognize this. It's very simple to call a RESTful service. You set the endpoint, you set the method, you set the body. That's it. You set a new HTTP object, and you send it with its request, and it gets back a response. And then I'm just pulling the text, because that's what I'm sending back. I'm sending the text of the PDF back from the service, and that's just all stuff I do, what I do with the data later. That's not calling the service. So very simple. This is a named credential. How many of you have ever configured a named credential? Anybody? Okay, anybody who calls a web service, same hands probably. You have to whitelist anything you're going to make a call to from Apex. A named credential actually does more than that. One, it whitelists it, but it also isolates the URL from your code. This is a low-code mechanism. If the URL changes, you don't have to change your code and then deploy it again and run your unit test. You just change it in metadata. So this is a great low-code feature of Salesforce for isolating the URL and the security information from your Apex code, which is a highly recommended practice. Otherwise, you're making work for yourself. You can also hook up security. I don't use security for this example, but you could. You could tie this to what's called an auth provider. You could use OAuth. You could use tokens. You could use whatever you want. I don't have any security on this. But you set this up, and then in the code, you set a constant, and then that's the pattern, and that's what pulls the URL from the named credential of that name, PDF parser. If you go back here, that's PDF parser. And then I can add on to that partial URL and make it longer, add parameters, whatever I want. And that's what I'm passing to the queuable class that will be executed. All right? The service, simple. Happens to have been written as a Go app. Anybody know Go? Google's it's not Node.js, it's Go. It's another, anybody work with Go? Okay, something to look at. Could be Node.js, could be ASP, it could be on Azure, it doesn't matter. It's what you like. Could be PHP, doesn't matter. The service I did not write, because I don't write that kind of code, so I called a friend of mine. Hey, Dale, can you write a service that scrapes a PDF? Sure, I'll have it done on Saturday. He did it on Saturday, he handed it back to me, boom, we were done. That's the beauty of microservices. I could delegate. Any language does not matter. I have a Git repo, and I'm going to quickly show you what this looks like. I think we have about 10 minutes left. Let's see if I can get through the demo in 10 minutes and still show you some links. So this is a Git repo with PDF parser. It's a Docker, it's Go, uses Docker, and there's very little in here. If I go look at the, let's go look at the Docker file. Here, this is the actual program. There's like 40 lines of code. There's nothing here. What's actually doing it, it's using a library. There's an IO util library, and it's calling temp file, and it's passing PDF convert, what got passed in, and it's writing it out. Boom, that's it. The rest of this is mostly error trapping. So it's incredibly simple as a service. It could be very complex. This is a simple example. And then what I'm doing is I have some code, a microservices manager demo, and I'm going to run it just to show you. It's also up there. And there's even instructions if you want to play with this. You can fork the microservice and create your own Heroku version. You can put these two classes into a standard developer edition org and just follow these instructions, and you can play with it. Okay? And then I'm going to run it from execute anonymous. I'm going to prove that it works. All right? So first I'm going to actually Before I do that, I'm going to show you calling the service from Postman. Anybody use Postman? The same guys who do, yeah, look at that, lots of people use Postman, okay. So I don't need that. I don't need that. Let me show you the Salesforce org first, where this is just a developer edition org. And what I've done is I've added a field to a contact object, a standard object. And the name of the field is called parsed text. And I've added an attachment. And I'm going to show you the attachment. The attachment is just a PDF. This is the PDF. And for this demo, all I want to do is I want to scrape that PDF and get it into the object. I don't have any parsing. I just want to prove that I can scrape the PDF and then I can plug it into the field, this custom field I created called parse text. Now there's nothing in parse text. Parse text is empty right now. All right, so if I go into edit mode, there's nothing there. Where is it? Parse text, very bottom. Parse text right here, right? So after I've run this, I want to see something there, okay? And I'm going to go into the developer console. Yep, not there. Let's launch the developer console. I'll launch it in a separate tab. And I'm going to close some things I was running a little while ago. I really wanted to make sure my demo worked. There's the code. We're not going to look at the code. I'm going to go to debug, execute anonymous. And that's it, just 2 lines of code. I'm giving it the ID of the contact, the parent to the attachment, and I'm calling the microservice manager demo, and I'm just saying, run the service, and here's the contact ID. Okay? Now, what's going to happen when I run this, I'm going to open the logs, and you're going to see 2 logs show up here, right? For anybody who's familiar with asynchronous Apex, you know that there's 2 Apex transactions happening, because the first one was the one I called from execute anonymous. That's, I believe, that one. And the other one is when the service got called. When the Qubble class finally got hit on the asynchronous engine on Salesforce, it ran that, the execute method. So there's 2 logs, right? And you could go in and look at the debugs, but I want to save a little time. So I'm going to simply go back to my record. No parsecs, let me refresh it. Ba-ba, there it is. Now, I'm going to show you, don't unplug. I'm going to show it to you from Postman, because I know you guys love Postman. Where's my Postman? Hello, there's my Postman. So this is Postman, that's the URL. I'm going to set the body, I'm going to binary, and I'm going to choose a file. I have a couple of other files here. So here's a real remittance record. This is the one that I showed you, and now I'm simply going to send it, and it's going to call the service, and it's boop. So this is a very different format, right? That is my actual remittance. I got 4, look at that, they sent me some money. Woo! I'm not rich, I don't get to keep it. I got to pay my contractors. But that's the service being called from Postman. So the key point here, I'll just quickly go back to the slides and we'll wrap up, is that you have the opportunity to do something outside the Salesforce platform when you need it. You can do one thing, you can do 100 things. It does not matter. And it can be built in whatever language you want. It can be built by a friend of yours or your colleague, and then they just give you the credentialed information or the security information, and you just call it. It's very simple. I'll quickly show you where you can get the sample code. There's some bit.lys that I've set up. The microservice manager demo is the one with the instructions. That makes a call to the microservice manager. So there's a dependency. You want to create the microservice manager class first if you're going to do this. Then you would create the microservices manager demo class because there's a dependency, and you know how Apex works, right? You can't have a class compile if the other classes that it's dependent on aren't there, right? Same thing. And that's the PDF convert is the name of this little service. Don't use my service. That's the real one. And the URL that I showed you, if you took a picture of that, please, there's no security on it. That's actually a production service, which I know is not supposed to, that's not very smart, but I always trust the people I deliver to. So what I'm going to say is just fork it and then create your own Heroku instance. And if you want, try putting security on it to see how the security piece works. All right? A couple of other takeaways. Who knows the Dreamhouse app? I know you saw a picture of it, but anybody played with the Dreamhouse app? Okay, that's terrible. You guys, that's shameful. The Dreamhouse app was built by Salesforce evangelists over the last 2 years, and it is a classic reference application, and it shows the platform off fantastic. It is a learning tool. It's a great application. It's based on an American real estate company. It has Lightning Components, it has low-code mechanisms, it has process builder, across the board. It is a reference app. Its purpose is for people like you to dissect it and learn. It is a learning tool, especially the Lightning Components. They're very sophisticated and they're great. It also has some call-outs. It uses a similar pattern. It calls to Facebook, it calls to Slack, it has bots. It's a very, very cool application. So you can learn a lot from it. Also, there are IoT applications, and they're all in GitHub. You can get the links right off of that website. There's 19 apps, so there's lots to chew on. This stuff is there for you guys, and when I say you guys, I mean developers around the globe to learn from. And we're going to talk all about learning at the closing keynote. Go check it out, okay? Go check out the Dreamhouse app. And how many of you have done the super badges, the developer super badges? Anybody done any one of the first 4? You've done one. Which one have you done? You don't remember. It was so exhausting. You don't remember. Which one have you done? The Lightning, right. Well, there are developer super badges. They're very challenging. But even if you're not going to complete them successfully, go try. You'll learn so much by trying to build these, and they are built the right way. And sometimes a little challenging to get the response to come back that you passed, but that's secondary. They're there as reference applications of real-world things that you can explore and you can try and you can learn from. And I always encourage people to always try to learn more. Always try to learn more. I designed the data integration super badge, and we use this pattern in that super badge. So now that you know this pattern, you get past a piece of the super badge. And that's, of course, how you learn. You learn the pieces, you apply them in real world, you do it, you learn more, you fail, you pick yourself up, and you do it again. So I encourage you to check out those super badges. But don't worry about certification, it's to do the work. And that's the most important way to learn. Just some pointers, I think I already mentioned. Go grab yourself a Pluralsight 30-day key. There's some great stuff. Anybody at the blockchain presentation this morning? Okay, so there's a great course on the Pluralsight learning platform that you can watch for free with one of these, all about using Apex to set up a private blockchain example. Dan Appelman, anybody know Dan Appelman? He wrote the Apex Advanced Developer Guide, another MVP guru in California. He wrote this course because he was experimenting with blockchain, and he wanted to see if he could implement it using Apex and a Salesforce database, and he did. It's a great course. It really teaches you about blockchain. So definitely recommend that. There's JavaScript courses on there for Salesforce, also by Dan. That's actually a free course. You don't even need to have one of these. You can watch it for free. There's other free Salesforce courses too. So I encourage that as a resource. There's 2 YouTube videos on microservices. One is by Paul Battison, another MVP, a couple of years old, and Sean of Maven's Consulting. And then there's one about monolithic application microservices on Heroku by Scott Klassen. He works for Heroku. Great YouTube videos. So I recommend those 2. Boom. Any questions? I think we still have some time. Wow, that was fast. I didn't think I'd get through in 30 minutes. How much time do we have? We're pretty good. Until when the door opens. Anyone have any questions? Come on, somebody has a question. It wasn't that clear. Could you understand me? Is there anybody who could not understand me? I won't be mad. Okay, good, because I'll use the same at the other ones. You are dismissed, students.